We want to start with chemistry practical. As you know, chemistry practical is divided into two. We have qualitative analysis and volumetric analysis. So this is qualitative analysis. So this deals with the detection of cations and anion present in a given salt sample. Meaning it deals with the detection of quality of salt samples. So we want to detect cation part and anion part present in a given salt sample. That is qualitative analysis. And what are the things? Let's see cations to be detected in the syllabus. To be detected. Cation to be detected. We have one. We have calcium ion. We have two. We have aluminium ion. We have three. We have zinc ion. We have four. We have lead 2 ion. We have 5. We have ammonium ion. We have 6. We have iron 2. We have 7. We have iron 3 ion. We have 8. We have copper 2 ion. We have 9. We have potassium ion. We have 10. We have sodium ion. These are the cations to be detected, and probably barium. These are the cations to be detected. So what are the anions? Anions to be detected. Anion to be detected. We have 1. We have chloride ion. 2. We have triisosulfate 4 ion. We have 3. We have tetraisosulfate 6 ion. We have 4. We have triisonitrate 5 ion. We have 5. We have sulfide ion. We have 6. We have chloride triisocarbonate 4 ion. These are the anions to be detected. So we are going to start with the cations detection. Cations detection. Cation detection. Cation detection. How do we detect cations? Two major tests are carried out on cations detection. Namely, we have 1. We have what we call flame test. We have 2, then followed by solution test. So we have flame test and solution test. These are the two major tests to be carried out on the cation or cation detection. Flame test. Let's label the flame itself. Let's label the flame itself. Let's level the flame is off. So here we have the air. These are the air. These are the air. So this one, maybe you draw it like this. You draw it like this. You draw it like this. Definitely there will be passage of gas. So this is gas. This is air for burning. Let me reduce the size. This is air. This is air. This is a non-luminous flame. This is a luminous flame. Luminous flame. And this one, we call it unburnt gas. Unburnt gas. That's the diagram of a flame. After the diagram, how do we use it? How do we carry out flame test on cations? So a solid salt sample, a given salt sample is moistened with a little quantity of dilute HCl on a spatula. You put it on a spatula. So the spatula is introduced into the burning flame of, that is non-luminous flame of a Bunsen burner. So the characteristic color in which the salt burnt is noted. That will give you the flame test. So this is what we are doing. Let's say this is the flame, the Bunsen burner. This is the flame, Bunsen burner. This is the non-luminous flame. Then you look for a spatula. Let's say this is a spatula. You know what a spatula is? Something like spoon in the lab. Then you put a salt sample here, call it spatula here. This is the flame, non-luminous flame, Bunsen burner. So here, a solid salt sample. Yes, you now introduce it into the flame of the Bunsen burner. Then it will be burning with a characteristic color. So that color is noted. So it should be noted that every salt burns with the initial color of golden yellow, because each salt contains sodium impurities due to the presence of sodium impurity. So let's see the salt or cation and their respective color. color. That is or characteristic color. We call it characteristic color under flame test. So one, sodium ion, it burns with yellow, golden yellow. Two, copper 2, this one burn with bluish green or deep green. 3, we have lead. Okay, lead 2 ion, this one is blue. 4, we have calcium ion, this one is brick red. 5, we have potassium ion, this one is lilac or crimson or violet. And finally, we have barium. This one born with light green. These are 6 you are expected to know as far as O level is concerned. Sodium ion, golden yellow, copper 2, bluish, and so on. This is what you are expected to know, these 6 for flame test. This is the end of flame test. The second one is we call it solution test. You can see that flame test is carried out on solid salt sample, while solution test is carried out on the solution of salt sample. So this is carried out on the solution of a given salt sample. So we talk of solution here. Now, the two common reagents or the two reagents that are majorly used for solution test are 1, talk of sodium hydroxide solution, and then ammonium hydroxide solution, or you call it aqueous ammonia. These are the 2 major reagents that are used to carry out solution test. But for further confirmation, the following reagents could be used. 1, dilute HCl, potassium iodide solution, acidified K2CR2O7, potassium ethyl 6. 4, you can use K4FeCN6. This is potassium hexacyanoferrite 2. K3FeCN6. This is potassium hexacyanoferrite 3. Why this one is a 2? Then finally, we have KSCN. This is known as potassium tau. Sulfur group is called tau. Instead of mentioning sulfur, you say tau zanate. That's the name. All these are used. So let's start. We have, if you want to carry out solution test, it must be reported as in a tabular form test, observation, then we talk of inference, test, observation, inference. Let's see the first one. A, you have solution A plus sodium hydroxide solution. You will add it in dropwise until it is in excess. You add in small quantity, later you increase the quantity. Having done that, look at what happens. The observation, you have white PPT, precipitate in dropwise, but when you add sodium hydroxide in excess, if the precipitate dissolves, check what happens to it. If the precipitate remains, so insoluble in excess sodium hydroxide, meaning precipitate still remain. That is calcium ion present. This is a chemical test for calcium ion. Any calcium salts, when you have sodium hydroxide dropouts and excess, you observe where precipitate soluble in excess. That is one. Each time you use solution, you use sodium hydroxide, you have to repeat it again with different solution, the same solution of another portion of solution A. So let's say you still have another portion of solution A plus use ammonium hydroxide aqueous, the dropwise and SS. Dropwise and SS. Here, no precipitate at all. No precipitate observed. Then you still have calcium ion present. So if you want to test for calcium ion, it's either you use sodium hydroxide solution or you use ammonium hydroxide solution. So sodium hydroxide solution, while precipitate, insoluble in excess, ammonium hydroxide is no precipitate. This is the chemical test for calcium ion. That is A. We are done with calcium ion. To test for calcium ion, add sodium hydroxide dropouts and excess, while precipitate insoluble in excess is observed. If you use ammonium hydroxide, no precipitate. We've got one. You have solution B plus sodium hydroxide now, aqueous, dropwise until it is in SS. It is in SS. In case of calcium ion, you are going to observe why precipitate is soluble in SS. But the more you have white precipitate in dropwise, but now soluble in SS, then three things are likely to be present. So it's either aluminum ion or zinc ion or lead-2 ion. Press one of. Do not use and use or you use comma. So one of these is likely to be present because they form amphoteric oxides. You know, Al2O3 is amphoteric, zinc oxide is amphoteric, lead-2 oxide, all these are that of tin, they are amphoteric oxides. Meaning they behave as both acidic and basic oxides. So this is what we have, 3. Then we go to solution B, another first portion of solution B. You test it with ammonium hydroxide again, dropwise and SS. Dropwise and SS. points and messes. So, in case of calcium ion, it was recorded as a low precipitate. But here, if you have white precipitate, so it can never be calcium ion. White precipitate, soluble in essence. You could have white precipitate, insoluble in essence. So white precipitate soluble in essence, you have zinc ion present. So if the precipitate is insoluble, it's either aluminum ion or lead-2 ion present. From this B part, figure 1, it shows that you can never use sodium hydroxide to distinguish between this, and this. It's not possible because they are going to, in each, you have white precipitate soluble in essence. So sodium hydroxide is not enough to distinguish between their solutions. But you can use ammonium hydroxide especially for zinc, because it is only zinc you have white precipitate soluble in essence. But for aluminum ion, the tool is to be white precipitate insoluble in essence. So ammonium hydroxide is enough. You can single-handedly use ammonium hydroxide to test for zinc ion as white precipitate soluble in essence. This is what you are going to observe. But if you use ammonium hydroxide to be white precipitate insoluble in essence again, so ammonium hydroxide is not enough to distinguish between solution of aluminum ion and lead-2 ion. So what you are going to do when this precipitate is formed, we now say Roman figure 3, precipitate in Roman figure 2 above, precipitate in Roman figure 2 above here, plus dilute ACl. We now add dilute ACl to it. Two things are likely to happen. Is either precipitate dissolves or precipitate remains. Where the precipitate dissolves, so aluminum ion confirmed for further confirmation. It's confirmed. Where precipitate still remain, on adding dilute ACl, then lead-2 ion confirmed. So how will you test for zinc ion? Zinc ion is tested for by adding ammonium hydroxide dropwise and essence. In dropwise, white precipitate, in essence, precipitate dissolve. That is chemical test for zinc ion. But for aluminum ion and lead-2 ion, add ammonium hydroxide. Both will form white precipitate insoluble in essence. But on adding dilute ACl, precipitate dissolves in aluminum ion, precipitate remains in lead-2 ion. So if you are asked, how will you test for aluminum ion? You say by adding ammonium hydroxide dropwise and essence. While precipitate insoluble in essence are formed. On adding dilute ACl, precipitate dissolves. How will you test for lead-2 ion? By adding ammonium hydroxide, while precipitate insoluble in essence is observed. On adding dilute ACl, precipitate still remains. That's the chemical test for lead-2 ion. If you cannot use this reagent, dilute ACl, there's another one we normally use for further confirmation again. Precipitate in 2 above again. Let's say 2 above. Plus, you use potassium iodide solution, or you use K2 acidified K2Cr2O7 solution. You can use this one as well. So, where you have yellow precipitate, aluminum ion confirmed. Where you have no yellow precipitate or no precipitate, then you have lead-2 ion confound. So if you don't use dilute HCl, you can use potassium iodide or K2Cl2O7. That is solution test for aluminum ion, lead-2 ion, and zinc ion. Then let's see that of ammonium ion. Ammonium ion. So I would like to start with, I will say C. Another solution C plus ammonium hydroxide plus sodium hydroxide, sodium hydroxide, then plus warm. You warm it. You warm it. Anytime you add sodium hydroxide to a solution and solution is warmed, then the gas given off is tested. See my video on how to test for gases. So a gas given off, you test the gas with litmus paper, you check the odor, you check the color. So a gas given off, colorless, choking smell, turns a moist red litmus paper red, and they form a dense white film with HCl, that is ammonia. The gas is ammonia. The gas is ammonia gas. So this one is as a result of presence of ammonium ion. So ammonium ion present. So what's the chemical test for ammonium ion? Any ammonium salts warmed with sodium hydroxide, a gas given off is ammonia. That's the chemical test. It will give off a gas, colorless, odorless, choking smell, turn moist red litmus paper red, turn moist red litmus paper blue, blue. The only basic gas is ammonia, and it forms a dense white film with HCl. This is the chemical test for ammonium salt. Warm with sodium hydroxide and ammonia gas is evolved. Solution D plus sodium hydroxide dropwise and until it is in excess. Dropwise and excess. If you have blue precipitate or light blue precipitate insoluble in excess, the precipitate still remain. That is copper 2 ion present. Copper 2 ion present. That's the chemical test for copper 2 ion. That is Roman figure 1. Roman figure 2. If you use the same another portion of solution D plus ammonium hydroxide, aqueous, dropwise and excess. Dropwise and excess. What you are going to observe in dropwise, you will see it to be pale or light blue or pale blue precipitate. On adding this in excess, ammonium hydroxide in excess, precipitate will now dissolve. Soluble in excess ammonium hydroxide to form a deep blue solution. So meaning in essence, the precipitate will dissolve. Not only dissolve, the color will be deep blue, from light blue to deep blue. That is another copper 2 ion present. So you can either use this To test for copper 2 ion, or use ammonium hydroxide. So that about copper 2. I've done copper 2. Let's see E. We want to see solution E plus sodium hydroxide solution dropwise and SS. If you have dirty green gelatinous precipitate, dirty green gelatinous precipitate, insoluble in SS, that is chemical test for iron 2 present. So the iron present is iron 2. How we test for iron 2? I have sodium hydroxide dropwise and SS. If dirty green gelatinous precipitate insoluble in SS is observed, then iron 2. If you don't use that, let me say Roman figure 1, Roman figure 2, you can as well make use of ammonium hydroxide. Solution E plus ammonium hydroxide aqueous dropwise and SS. Dropwise and SS. This one will give you the same thing, the same observation as that of sodium hydroxide, dirty green gelatinous precipitate, insoluble in SS. Insoluble in SS. You can see, you can use sodium hydroxide or ammonium hydroxide, the same observation. We have iron 2 present. Iron 2 present. So that is how to test for iron 2. Another test you can use for iron 2 is to use potassium hexavalent or potassium hexavalent 3. If you use 3, solution E plus K3 FeCnC solution. This is potassium hexavalent 3. We are going to have deep green precipitate. Deep green precipitate. Is it green or blue? Deep blue, not green. Deep blue precipitate. We're going to have deep blue precipitate. So what we have here is iron 2 present. Deep blue. Then what happens if you use solution E plus K3 FeCn, K4 CN6 solution, and you have light blue precipitate here. Light blue precipitate. What you are going to is still iron 2 present or confirmed. I would prefer confirmed for further confirmation. Say confirmed. So you are finally confirmed it. So look at the difference. Potassium hexavalent 3, potassium hexavalent 2. Now, if it is 3 for 2, it will be deep blue. That is what you can use for that. Let me see F now. Solution F plus sodium hydroxide aqueous dropwise it is in SS. If you have light blue precipitate here insoluble in SS, it's copper 2. If you have dirty green gelatinous precipitate insoluble in SS, it's iron 2. But you have reddish brown precipitate. reddish brown precipitate, insoluble in SS, that is iron 3 present. This is the chemical test for iron 3. Let's say this is 1. 2 is another fresh portion of solution F plus ammonium hydroxide solution dropwise and SS. Dropwise and SS. The same observation, reddish brown precipitate, insoluble in SS. Reddish brown precipitate, insoluble in SS. Then iron 3 iron present. So for further confirmation, just look for a first solution of solution F plus K2 Fe, okay, plus K2 Fe, K4 FeCN6. This is potassium hexanovery-2 solution. Hexanovery-2 for iron 3. It also gives you deep blue precipitate. Deep blue precipitate. So it means hexanovery-3 and iron 2 deep blue. Hexanovery-2 and iron 3 deep blue. Hexanovery-3 and iron 2 deep blue. 2 deep. 3 deep. Deep blue precipitate. So we have iron 3 confirmed. But let's say you use hexanovery-3, okay, 3. So solution F plus K3 FeCN6. 6 minus 3, 3. That's hexanovery-3. This is 6 minus 2, 2. Hexanovery-2. Solution. This one will give you light blue precipitate, light blue. So we have iron 3 confirmed. We have another special test. Let me take it to 5. Let's say you have another portion of solution this plus KSCN. This is potassium thiocyanate. Potassium thiocyanate solution. You add it to solution F. Let's say you have blood red coloration. Blood red coloration. That is iron 3 also confirmed. Take note of that. Sometimes we say if you add it solution F plus KSCN aqueous and you have pinkish coloration, it's no longer iron 3 but iron 2 confirmed. But for iron 3 it will look like blood. So this is the end of solution test in chemistry. This is the end of solution test. So our next video, we are going to start with anion detections. And there are 2 tests on the anions. We have complete test and the preliminary test. Please comment, share, like, and subscribe. God will bless you as you do that. Thank you.